The second order non-homogeneous DE, we already know how to solve this. Heck, we've probably solved this guy before. We could find our complementary function, our complementary solution by setting this thing equal to 0, solving the homogeneous version, finding a particular solution using undetermined coefficients, guess, check, and then just say y is yc plus yp. We know how to do this problem. So that would be an easy way to check the answer we get. We're just going to solve it using a different method. So we're going to take the Laplace transform of both sides. Laplace transform is linear, meaning I can distribute it. I can say Laplace transform of y double prime minus 3. I can pull the minus 3 out. Equals Laplace transform e to the negative 4t. Oh, and Laplace transform is used to solve initial value problems. I do need to give us a couple of initial values here. Y of 0 is 1. Y prime of 0 is 5. Maybe now looking back, maybe I shouldn't have done a problem with the 5 in it, since my 5s and s's tend to look alike. I'll try to be careful. Okay, this one we're just going to look up in our table. So we go to our Laplace transform table, and I'm looking for the Laplace transform of e to the at. So e to the at, I get 1 over s minus a. So in my case, in the one we have, a is negative 4. So on this side, we'll just get 1 over s plus 4. We don't have to do these by hand anymore. We've proven, assume we've proven everything on that table. So we just look it up in the table. Over here, I just wrote all these down. The Laplace transform of y double prime is s squared capital Y. Capital Y means the Laplace transform of y. Minus s y of 0, little y of 0, minus y prime of 0. We know both of those. Those are here. Minus 3. Laplace transform of y prime is s capital Y minus y of 0 plus twice the Laplace transform of y. That's what we're calling capital Y. All right, let's fill in all the things we know. So that's s squared capital Y minus y of 0 was 1. Y prime of 0 was 5. I'm going to go ahead and distribute my 3 here. Minus 3s capital Y minus 3 times minus 1 would be plus 3 plus 2y. Make sure you keep that looking capital. Okay, now my goal is to get y equals stuff. So I want to group all my y's together, get everything else to the other side. So how many y's do I have? I have s squared minus 3s plus 2, all times capital Y, and that will equal 1 over s plus 4. I've got these guys here. So that would be minus 2. On the other side, that would be plus 2. And then this minus s plus s. So capital Y then would be, I have to divide everything by that, 1 over s plus 4 times s squared minus 3s plus 2 plus s plus 2 over all that stuff. Okay, we're almost done with the problem. From this point on, it's just algebra. We've turned a calculus problem into an algebra problem. I should point out, by the way, that the thing we have here times y is just our characteristic polynomial that we would have gotten if we'd solved this problem the old way. Okay, now my goal from this point on, once I get capital Y equals stuff, my goal is to take the inverse Laplace transform of both sides. The inverse Laplace transform of capital Y is the thing we want. Little y equals the inverse Laplace transform of this right-hand side. That's all we have to do. Find the inverse transform of this side. If I had something that looked exactly like this in my table, I'd be done. I just read it off the table, write down the answer, I'm literally done. Problem is, my table isn't that complete. It doesn't have stuff that's quite this complicated. So I'm going to have to use partial fractions here and break this down into things that I can find in the table. And basically on all these problems, every single one of them, if you're not using partial fractions somewhere, you're not doing it right. So let's do that. So I need the space. I'm going to erase all this and write what we have. All that stuff you guys learned about partial fractions in pre-calc and then used a little bit in Calc 2, you're going to use it a lot now. Okay, so right now we have capital Y is equal to, I'm going to simplify that right-hand side, combine those fractions together. It's actually not necessary. We could have done this one step at a time, but I think it might be easier this way. Which I could, this guy here factors. Let's skip a step here and say that's s minus 1, s minus 2. My goal now, in order to find things in my table that look like what I'm going to write, let's break this up into linear factors. A over, I want to match what I have in my notes, or yeah, okay. Or I'm going to disagree with myself. All three of these guys are easy. These are all exponentials. His inverse Laplace transform is e to the negative 4t. His is e to the negative, e to the t. His is e to the 2t. All of those guys look like this guy right here times a number. So I just got to find that number for each one. I just got to find A, B, and C, and then I'm done. It's really easy. So we have to do this partial fraction decomposition. So we want s squared plus 6s plus 9 equals, you may remember how to do this. If not, look up partial fractions. So multiply everything, both sides here, by this denominator. Each fraction is going to get the stuff it's missing. This guy already has an s minus 1, so on top, he's going to get the two guys he's missing. And now we solve for A, B, and C. We could, and there's nothing wrong with it, expand all this out and equate coefficients. For example, I know if I were to distribute everywhere, I would get an A times an S squared plus a bunch of junk, plus a B times an s squared plus a bunch of junk, and a cs squared and a bunch of junk. Over here, my s squared term is 1. The only way two polynomials can be equal for every value of s is if all the coefficients are equal. So a plus b plus c must equal 1, because I have 1 s squared over here. I could do all that and get a system of 3 equations and 3 unknowns. And it's nasty, but it's doable. Or I could use the cover-up method. That's my preferred method. Plug in strategic values of s to make parts of this thing cancel out. For example, if I plug in s equals 1 to every single s in this equation, I get a 0 here. 1 minus 1 is 0. I get a 0 over here. The only thing that will be left will be the b term. I can solve that for b. So if we do that, we'll get 1 plus 6 plus 9, plugging in a 1 for s, equals 0, plus b times 5 times negative 1, plus all that will be 0. So what is that? 16 equals negative 5b. So b is negative 16 over 5. Check my notes, make sure, yep, that's what I got before. Plug in any value of s, but it's helpful to plug in strategic values, values that make factor 0. If I plug in a 2, I'll get 4 plus 24 plus 9 equals 0. Plus, oh, that makes this guy 0. C times, plugging in a 2 for all the s's, 6 times negative 1 times 1. What do we get over here? 28. Oh, my numbers weren't working out. 2 times 6 is not 24. It's 12. So I get 25 equals 6c. So c is 25 over 6. And then finally, the other 0, the other root here, plug in s equals negative 4. And you'll get 30a equals 1. So a equals 1 over 30. Okay, so what good did that do us? Now we can do inverse Laplace transforms. So I end up with capital Y equals, using all those values I just found, 1 over 30 times 1 over s plus 4. I'm going to write these on top. What was b? Plus negative 16 over 5 over s minus 1. 25 over 6 was c over s minus 2. Nobody asked me for y. This is a function of s. I need to convert him back, go back to the t domain. So I take the inverse Laplace transform of both sides. And that's linear, so I can distribute. The inverse Laplace transform of capital Y is a little y, the guy I'm after. That's my goal. That's what I was trying to get. Again, the Laplace transform is linear, so is its inverse. All these factors just factor out. The inverse Laplace transform of 1 over 30 s plus 4, I just pull out that 1 over 30. and I want the inverse of 1 over s plus 4, I look that up in my table. One over s plus 4, so a here is -4, will be e to the -4. So this will be 1/30 e to the -4t. Remember, in t domain, my variable is t. So I just do that for each one. And now I have solved this dE without doing any calculus at all. I get y equals 1/30 e to the -4t minus 16 over 5 e to the t plus 25 over 6 e to the 2t. There is the solution to this initial value problem. And I got there without doing calculus. I did algebra, a whole bunch of nasty algebra, but just algebra.